Warahmatullahi wabarakatuh. I'm Akif. I'm from Civil Engineering student. Today I'm going to do an explanation about mini project in ECG263. This project also involved my two group members, which is Mohaiman and Anik. The purpose of our project is to study about the soil characteristics and learn how to conduct an experiment properly. Basically, soil in area of UiTM Jengkau Pahang is coarse grain soils, specifically gravel. Generally, the test that we conduct in the lab is about detailing of soil and experiment. So basically, this mini project contains 4 tests, which is moisture content test, proto test, sieve analysis test, and field density test. Let's get into it. First test is proto test, which is we want to find moisture content of the sample. Here we set up the sample using mold and have 3 layers in it. This test also use rammer and extruder machine to make the sample compact so that there is no void in the sample. Then we use oven to get weight of dry soil. Next we have field density test. This test is to find dry soil of in situ soil. This test was implemented in lab for calibration stage. Then we make a test at site, which is to find the wet soil that's same depth with calibration cylinder in the lab. Then we take several samples of wet soil to find the moisture content of soil. Next, in order to get the size of sample, we also implement sieve analysis test, which is have 3 stages. This these tests are using the shaker machine to separate each size of aggregate. Then we will know the quantity of each size of the aggregates. Next, we also have moisture content of soil test. This test obviously to find moisture content of soil. This test start with mix between water and soil to get the wet soil. Then we use oven to dry in the soil. Then we can find the moisture content of the sample. In addition, this test take 3 readings, so that means we have 3 samples of soil. Then we can find the average moisture content of the sample.
Now, for findings and discussion, we will go through the test one by one. For the first test, we will go through the standard proto test. For the standard proto test, the main objective of the standard proto test is to find the optimal moisture content of the soil. When we conduct the experiment, we will tabulate two tables and we will enter each of the data. For example, we will measure the weight of mold, weight of wet soil, and weight of dry soil. From the data, we will create a graph dry density versus moisture content. For the moisture content, we will calculate using the formula mass of water over mass of dry soil times 100. And when we get each of the moisture content, we can plot the graph, and from we will choose the peak point of the graph, and from that point we will obtain the optimal moisture content. Okay, for the second test is field density sand replacement method. For this test, the main objective of this test is to determine the dry density of in situ soil. And for this test, there will be 2 steps, which is leg and field. For leg, we will measure the weight of per ring cylinder, weight of calibrating cylinder, and weight of wet soil. For field, we will go to site and we will dig the soil to collect the sand, and the sand that we have collected, we will go to lab and measure the weight, and we will divide the sand into three sample, and from the sample we will put it in the oven and we will get the moisture content. Based on the result that we have get, the first sample moisture content is 5.96%, the second sample is 7.4%, the third sample is 7.53%, and from the three moisture content that we have get, we will calculate the average moisture content, and from our data, the average moisture content that we have get is 6.963%, and from the average moisture content, we can calculate the bulk density of the soil. We can calculate the bulk density of the soil by using the formula total mass over total volume, and based on the data, the bulk density that we have get is 1278.34 kilograms per meter cubic. And when we have get the bulk density, we will calculate the dry density of the soil. From our data, the dry density that we have get is 160.53 kilogram per meter cubic. For the third test is called moisture content for soil test. The main objective of this test is to determine the moisture content that the soil has. For this activity, we would use 3 samples of soil, and we will record some data like weight of moisture pen, weight of moisture pen plus wet soil, weight of moisture pen plus dry soil, weight of dry soil, weight of water, moisture content, and average moisture content. For this test, based on our data, the first moisture content sample that we have get is 23.64%. The second sample is 16.67%, and the third sample is 21.39%. And from the moisture content data, we will calculate the average moisture content, and to get the moisture content for each sample, we will calculate by using the formula mass of water over mass of dry soil times 100, and we will get the moisture content for each sample. Then we will determine the average moisture content by using the moisture content for each sample. For the next test, this is the final test of this project, which is the particle size distribution sieve analysis, and the objective of this test is to determine the percentage of different grain size of our soil sample. And to conduct this test, there will be 3 stages, and we need to fill up all the 3 stages in order to get the percentage of different grain size. For the first stage, the soil passing that we have get is 1817.08, and for stage 2, the soil passing that we get is 672.37, and the stage 3, the soil passing that we have get is 145.73, and the total soil passing that we have get is 1992.80. And to complete this test, we need to plot a graph based on the sieve analysis table that we have filled up. And when we plot the graph, we can identify what is the type of our soil sample, and based on our data, the soil classification that we have get is well graded very sandy gravel, because the percentage of gravel is the highest. The second highest is sand, and the lowest percentage is silt. And the conclusion is this experiment is very essential for us to do, to make sure that we are able to get the percentage of the different grain size, and we will know what is the type of our soil.
This moisture content test allowed us to obtain the specific gravity of soil, which is the primary objective of this laboratory activity. This test is crucial for construction work, as it provides a reliable method for testing soil sample outside. Understanding the specific gravity and moisture content helps in making informed decisions during construction. Next, let's move on to conclusion. We have achieved our target objective for this experiment, which are: in the proto test, we have successfully determined the compaction characteristic of the soil sample, providing valuable insight into how average moisture content and dry density affect the soil. These tests also help us identify the soil type using basic principle of the standard proto test, which is crucial for understanding soil behavior in various engineering applications. In the feed density test, we measure the dry density of the situ soil. Testing 3 samples, we found one consistent dry density. This shows the crucial relationship between moisture content and soil density, which is essential for proper soil compaction and stability in construction project. Understanding this helps ensure the safety and integrity of structure built on the soil. The moisture content test allows us to obtain the specific gravity The moisture content test allow us The moisture content test allowed us to obtain the specific gravity of the soil, which is the temporary. Lastly, the sieve analysis test enable us to determine the percentage of different grain size in the soil by plotting a graph. This test is essential for identifying soil types and understanding their composition, which is critical for construction site assessments. The ability to perform a sieve analysis test allows us to classify soils accurately and apply this knowledge in real-world engineering projects. So that's all from us. Thank you.